My name's Devin Sandon from Venture for ClimateTech, and I'm going to be the moderator for this panel. If all of our panelists could introduce themselves quickly, I'm sure we'd all appreciate it. Nina, would you like to start?
Yeah, sure. So I'm Nina Ali. I'm a consultant with First Matter, where I advise startups on commercialization and climate tech and accelerators as well. Prior to that, I was with Elemental Accelerator, focused on designing and managing the strategy track and also advising startups. And I started my career with almost a decade at Siemens, focused on introducing and commercializing new energy technologies for the transition to global markets. So really excited to be here with Nneka and Claudia. And Devin, of course.
Great. Thank you for joining us. Claudia?
Hi. Yes. Hello, everyone. Thanks for being here today. And I'm Claudia Maldonado, founder and CEO of Atrevida Science. And we are working in the exciting world of offshore wind, where our goal is to bring down the levelized cost of energy. And we are doing this by introducing next generation blade designs to this $17 billion industry. And as we see offshore wind grow, the industry is looking to longer blades to capture all that energy. And a big reason for that is that the wind resources over water are so much greater. But longer blades, they do create other problems. And so to overcome those challenges, our design changes the blade's profile in real time, which today's blades can't do. And this technology reduces LCOE 50% by 2030. And so it's a huge enabling factor in the energy transition. To tell you a little bit about our team, we are a team of 8. Most of us are based in Amherst, New York. We are a spin out from the University of Buffalo, where our core team was formed about 3 years ago to commercialize active morphine blades. And so a little bit about me, I'm an industrial engineer. I spent many years in manufacturing, working on modeling and simulating large components, how they're made, how they're transported, and the models that I designed for companies like Westinghouse saved over $20 million for large-scale energy deployment. And so more recently, though, I've teamed up with the Energy Systems Design Research Group at UB and with the work that they're doing on blade design. And then in between industry and leading Atrevida, I went down a different path for a few years where I taught middle school math at a Title I school in Austin, Texas. And I learned a lot, bringing out the best in others, inspiring trust, setting a vision and the goals to get there, and working with a lot of different stakeholders. And it's really all of these experiences that led me to founding Atrevida Science. And so I'm so happy to be here to talk about accelerating the future of renewable energy with my fellow panelists, Nina and Nneka, and our moderator, Devin. So thanks so much for this opportunity.
Thank you, Claudia. And Nneka, could you introduce yourself as well?
Absolutely. My name is Nneka Uzoh. Or actually, I just got married, so I keep forgetting my new last name. So Nneka Chibuli. I'm Senior Vice President at Align Climate Capital. We are an investment firm that's investing across the climate tech platforms. We're investing in tax-efficient solar, as well as infrastructure, as well as growth equity in startups. Before joining Aligned, I worked with Nina at Elemental Accelerator, where I was the Director of Energy Innovation. And before that, I worked at PG&E and NextEra Energy in a variety of finance and strategy roles. Really excited to be here to talk about my favorite topic, energy.
Thank you, Nneka, and great to have you all. Hopefully this will be a great conversation. So to jump things off, when we're talking about wind, can you walk us through some of the challenges that face current wind turbines today? And why is something like dynamically changing blades revolutionary in this industry? And I'm going to throw this to Claudia first because it's her area of expertise.
Thanks, Devin. So there are a lot of challenges. You know, if we talk about wind turbine systems and the blades, they really are engineering miracles if you look at them. To give you a quick example, the blades of the past could easily fit in your driveway, and today's blades are longer than a football field. So there is a lot of impressive work that's been done over these years, but there are a lot of challenges that we're realizing as we make those blades larger. And so in the last 10 to 20 years, we haven't seen radical improvements in blade design. We've seen great advances in materials, great advances in various ways of feathering and making these blades lighter, but a radical improvement to get us back on that LCOE curve reduction, which we haven't seen in the last 10 years, is really where we need to go. So that's one of the challenges. Another one is that you're talking about decades old of manufacturing. So there's an established way of making those blades, and to change that can be a high cost. But at the same time, we're talking about rigid blades, designs that are fixed, and that makes things like transportation really difficult, and getting it to the site, to the wind farm, very difficult as well.
So, Claudia, if I can interject for a second, I think most of our audience will know, but just in case they don't, can you explain what LCOE is and why it's so important in the context of wind and renewables?
Yeah, thank you, Devin. So I forget sometimes, not everybody knows maybe what that is, but LCOE stands for levelized cost of energy. And it's basically a common way to explain the economics of renewable energy, or even a traditional source like fossil fuels. And it's how we compare one source of energy over another. And so the drive is to lower that cost of energy. And like I said earlier, it has leveled off some by the effect of longer blades, because sometimes these longer blades can create other problems down the road, like downtime or maintenance from that downtime.
Okay, that certainly makes sense. So obviously the blades are issues. Are there other issues that you are seeing, Nina or Nneka, that also can tie into this, or how do you view this issue?
Something that Claudia and I have talked about earlier are just some of the regulatory and industrial constraints that prevent the growth of this industry. And I think sometimes when people think about renewable energy, they think about it as all generally being the same, like it's a clean source of energy. But in the reality, each of these technologies are so different in the way that the energy is generated, so therefore their supply chains are very different. And one of the things that is challenging on top of the way that these blades are manufactured, it's also the workforce, getting specialized workforce, and additionally, the shipping of technology. So one of the challenges that we have is the Jones Act, which is policy that was designed to protect US manufacturers, which says that only US built and operated ships can move between US ports. So if we're interested in building offshore wind and building a whole economy around it and surrounding it, we're going to need a lot more ships, which our country hasn't been building at the same rate that it used to back, in the good old war times, which is not really that good on both sides.
Okay, that definitely makes sense.
That's very interesting, Nneka. I think I didn't realize that act was a thing, and now must really be a barrier for offshore wind. So definitely something to look at. And Devin, to your question, to add and build off of what Claudia has said, if you look at the history of wind power, I don't know if any of you, probably some in the audience, have gone out to certain windy areas of California, driven through, and you see those tiny little wind turbines from the 70s and 80s. And like Claudia said, they could really fit in your driveway. They're so small. They're on the kilowatt stage. They don't really work anymore. And fundamentally, all of renewable energy, and especially wind power, has been driven by their cost reduction of LCOE. And the fundamental way which they do that historically has been scale. So get the turbines bigger, generate more power, make the towers as tall as possible, even hit the level at which the FAA starts to regulate the height, because this becomes a concern for aviation, and make the blades bigger and bigger and bigger. And this is wonderful because it has a path to continuously grow. And there's a significant amount of competition in the wind OEM space, significantly more than there used to be 10 or 20 years ago. So it's rapidly driving that size increase, if you see across all of the different manufacturers. But the issue is that we still need to get the cost down, as Claudia said, significantly from here to be able to get to widespread adoption. And the sort of trends that have gotten us to this point in the dramatic cost reduction we've already seen will not be enough to get us to the next stage of cost reduction. There's a theoretical limit to how big these turbines can get. I don't know what that limit is, but there are all sorts of barriers and boundaries that will prevent it from getting to the point where this is the only innovation. And that innovation is comfortable for OEMs because they're used to making them incrementally bigger, incrementally bigger, incrementally bigger. And this comes with a sort of tolerable and understandable risk profile. But they're hitting a point now where margins are so unbelievably tight across competition, where that limit is being hit, and where they're going to have to see fundamental big changes in the way that the technology works, like Claudia's technology, that will allow us to get to where we need to go in LCOE.
Okay, that was a great explanation. Thank you for that. So As we progress towards a world where our cities and economies are powered primarily by renewable energies, assuming we solve these big challenges, what are other key areas that are going to need innovation to enable this to actually have the impact we intend?
Well, I think the grid is the number one thing that I think about. I'm a grid-centric person. I started off my career in the utility, and we've seen challenges of resilience across the country. Most notably, we saw those winter storms in Texas that knocked out ERCOT. And now we're seeing that there are a lot of areas that need transmission level lines. There is an increase in demand response and a lot more smart devices that just the quality of distribution and transmission just has to go up. A lot of it is already outdated. We're having challenges with transmission lines causing fires in California and other places. So just grid hardiness is a thing. And I think it's easy for us to talk about cities because urban areas are so dense and it feels like a lot of change can happen within one square block. But I think when we talk a lot about kind of urban tech or renewable smart cities, we also leave behind people who live in towns and rural areas who are least likely to be served by any of the innovations like, EV chargers or access to solar, and a lot of the programs that exist in larger cities are more developed in wealthy areas.
Yeah, and I would like to say that what Nneka's talking about there is, like she said, it's a challenge, and so that brings along with it an opportunity. And with Nina, bringing up the physics, the limits of these components is all really another challenge, and that kind of feeds into answering your question, Devin, about another challenge is the the supply chain. So I mentioned earlier that making a radical change or proposing something new like what we're doing would be difficult if you're trying to fit it into an existing manufacturing facility. But our supply chain needs to be brought up to speed to be able to provide these components for our domestic projects. And so this is the perfect time to, explore some of those innovations that are not allowing that LCOE curve to continue to go down, because we're using some of those really amazing designs over the last 40 years, but they are, like Nina said, incremental. That's what we're looking at now. And so, the supply chain, beefing that up and getting that to a place where we can actually make our own blades and deliver them to those wind farms is really crucial.
I'd actually like to add, Claudia, that about 8, maybe 10 years ago, it looked like there was going to be, as I think many people might remember, a really significant introduction of offshore wind in the US, with Cape Wind leading the way. And so there actually was a scale up of maybe not the supply chain, but of everyone getting ready with offices and jobs coming to the US centered around offshore. And when Cape Wind didn't materialize at that time, everything in the US was shut down. So we're now at that point where we have to rebuild those jobs, that supply chain, the expertise in the country, and that will certainly come. But it's just a shame that we didn't have that anymore from what we did have already before. But I'd also like to build off what Nneka said about the grid, which I think is an excellent point. And Nneka and I used to nerd out about grid technologies together. So not surprising that I'm building on what she said. But something that's particularly interesting about the advent of renewable energy in general is that historically load flow patterns were pretty predictable. We could understand most likely how, and doing 10-year planning out on transmission upgrades or distribution upgrades, you could understand what the load profile and the generation profile would look like. It was very predictable. And now with the management and the influx of having to dynamically change between renewable energy sources, those load flow patterns and that power flow is no longer so predictable. And this causes some very serious problems for voltage and reactive power on the grid, but also for inertia, which comes from the ability of rotating mass to be synced to the grid, which renewable energy doesn't have. So there are some, there's been a lot of emphasis on software solving the problems of the grid, which is wonderful. And there has been a very significant advancement in the last 10 years, but we need 2 more things. We need fundamental changes in how planning is done to account for these dynamic needs, which has already happened in some places, but for the most part, it's been very reactive because most utilities haven't understood the magnitude of how much this is going to change. They haven't experienced it. They haven't felt it yet. And most utilities are responding to these problems reactively. And we have to shift to a proactive stance to be able to truly get that kind of penetration. And we need innovation in hardware, not just software, which we know is significantly more difficult to achieve in risk-averse industries. So I think that is, going to be a big area of focus in the next decade.
Okay.
I think when you say hardware, that also almost automatically makes me think about storage, and going back to circling in our conversation about the levelized cost of energy.
Yes.
There's that, famous triangle, like, do you want something good? Do you want to have it fast, or do you want to have it cheap? And as our technology kind of increases in one area, like, it's either going to be more expensive, it's going to be not as fast, and we're just constantly rebalancing. And I think the market pricing is coming down as, companies like Atrevida are in the market, but also as policy is demanding changes. So in states like California and several other states, there are policy mandates that are part of, utility rate cases, et cetera, which are requiring the procurement. This is sounding very boring, but when you're requiring things like procurement, that means that all of a sudden the things that were kind of out of line for companies to purchase in terms of expense automatically become baseline in terms of cost. So there's also another part of this where, like, there's market pricing and technology, but there's a big policy implication here as well.
That definitely makes sense. So I'm actually going to jump to one question that came from the audience quickly in relations to Claudia's comments about supply chain and the fact that we don't have good ways of manufacturing this effectively. We're using old systems, etc. So we had a question about whether or not there might be an application for 3D printing to construct large blades on site rather than transporting them. I know that you have a manufacturing background, Claudia, so I was wondering if you could speak to that at all.
Yeah, thanks, Devin. So that's a really good question. There's a lot of applications for 3D printing in offshore wind or wind in general. They've done, the national labs have worked on a mold that is 3D printed, which is a huge help in terms of being able, those molds are very expensive, they're very large, and when you need to make a design change, it's very costly. But if you can 3D print that mold, that is a significant cost reduction in making those blades. As far as printing blades that way, I mean, we've done sample blades like that to take into the wind tunnel on a very small scale. And I think they're still trying to figure out, and I think over time that technology is getting better and better. And with wind turbines, there's just so many dynamics involved. So, you have to have a certain amount of stiffness, a certain amount of structural integrity, and you can't be too heavy either. So all of that, these are some trade-offs. These are some design trade-offs that happen. And so 3D printing may find a place in a part of the design of a blade over time. It's hard to tell right now. It's probably early, but definitely they've been used in the manufacturing for molds, and that has been tremendously helpful.
Great. Thank you for your insights there, Claudia. So continuing with the trend of talking about renewables at large, with levelized cost of power coming down for solar, for wind, for all these different sources, we seem to have viable renewable energy sources coming onto the grid now. So what are the barriers that are stopping widespread adoption? Why aren't we seeing higher utilization of these resources?
I can jump in first this time on this one. I think at the end of the day, we've seen an unbelievably impressive reduction in the cost of especially wind and solar. And now, starting on the curve of energy storage over the last 10 years, I don't think anyone could have predicted that we would get to this place so fast, which is very exciting. But at the end of the day, the cost of a renewable kilowatt hour or megawatt hour is directly tied to the strength of the resource. So we see a lot of exciting headlines about, the new cheapest source of solar power hitting 2 cents a kilowatt hour or whatever we're at now. But, if you put a solar panel or a solar farm in California, it's going to be 1/3 of the cost per megawatt hour as it would be if you put it in Oregon, and maybe 1/4 of what it would be if you put it in New York. So we've gotten to a lot of places where the economics of renewable energy are very attractive. But at the end of the day, a lot of places are resource poor. So especially if you look at like the East Coast of the US, doesn't have anywhere near the natural resources that the West region does, but has the load centers. So that's, I think, part of the reason why offshore wind is very attractive. And I'm sure we'll get to that later in the conversation. But it's all of the different drivers that help push this forward. If we want widespread adoption, the only driver that matters is economics, and everything else is in support of economics. So I know I'm a broken record on this panel, and I'm probably going to keep talking about it, but it's all about getting the cost even further from here, because there's certain regions of the world where we're there, but there's many regions of the world where we're not. And even in the regions of the world where we're there, we hit theoretical limits now without energy storage needing to come down dramatically in cost. So there are all sorts of other issues, but I think this is the fundamental one.
Yeah, and I think that both from what I heard Nina and Nneka both talking about, the energy storage issue is an important one, because as we look at the deployment of offshore wind, say for example on the Northeast coast, the big reason that all of us are talking about that is because it's such an abundant resource of wind. And if you look at the power curve for producing energy from a wind resource, you really only have two ways of impacting that, and that's the longer blades or a better wind resource. And so we're trying to do both. But I think there's also an important place for things like hydrogen. So, we have the opportunity to leapfrog what our European neighbors have done with offshore wind, because they've been doing that for 20 or 30 years. And there's a lot of infrastructure in places that we could use that kind of excess energy from offshore wind to produce hydrogen and then funnel that back to to shore. And so there's even things beyond what we think of sometimes. There's all that abundant resource, and we could actually make hydrogen, and if we needed to store the energy for when the wind isn't blowing as well in a particular time frame, then we can do that. And so like Nina mentioned a minute ago, that's a big reason why wind on the Northeast coast is a great resource. The winds tend to blow stronger in the daytime, and that's exactly when your load is happening. And so that's an important thing to consider, that we have the opportunity to do more than just provide energy, but we could even store it or make other forms of energy like hydrogen.
Do you have anything to add on that, Nneka?
I think they got it. They covered it.
Great. And I love the tie-ins between the opportunities and the challenges that we just talked about, because like transmission bring down the costs, that you can take those areas with lots of resources and connect them to areas farther away and like broaden the range that you can actually efficiently transmit energy is really, really exciting. If we have something to be excited about, do you think it's fair to say that we have sort of a virtuous circle where there are all of these challenges, but as any of them are tackled, the opportunities for everything else becomes better? Speaking to the hydrogen play for wind and all of these other transmission issues and grid issues.
Yeah, absolutely. I mean, I think, it took us, 100 years to get to where we're at in the current power system, and we're looking to reinvent it all as fast as possible. And on top of that, our load projections are growing and growing and growing with the amount of, new technologies and electric vehicles and things that are coming online. So it's really exciting how far we've come, but we've still only made a small dent in the opportunity of everything that needs to change. And I think there's a lot of excitement among even the big companies that have to reinvent themselves, the oil and gas companies, the traditional OEMs, the ones that didn't understand how to find their future in renewable energy, because the barrier to entry in solar and onshore wind was so low compared to traditional energy sources like nuclear or fossil or coal. And now with hydrogen and with offshore wind, they can see their future in that technology. So it's not just regulators and independent power producers and certain utilities who will be driving it forward. I think it's also the heavyweights of the traditional incumbents who will also be putting their weight behind this driving forward. And I think they can see how they survive the decline of fossil fuel into, a different future.
That definitely makes sense. So earlier we talked about how there are heavy loads on the East Coast, but there aren't really abundant resources there, at least for solar. So that seems to be one of the driving forces for establishing offshore wind in the Northeast. But what are some of the other driving forces, economically, market, technologically, environmental, that you're seeing propelling this movement?
Well, I think that, hearing Jigger Shah talk about how, a lot of really good ideas out there in the past that maybe never got traction are now seeing some traction. And it sounds like a lot of it has to do with the demand. That's something that if it isn't there, it's pretty tough to, even a great idea. And even like you said, an idea that is lower cost still has a lot of hurdles to overcome. And so that's been really, a big part of it, I think. I mean, if you look in New York alone, right now, 27% of our electricity is already from renewable sources, but we're looking at by 2030, I think it's 70% and going net zero by, I think it's 2040. And so that doesn't happen by doing the same old thing. That happens by really looking at these renewable energy technologies and looking at innovations that can boost them up to levels that we haven't seen in a while because we've been doing some of those incremental type of improvements.
Yeah, I think the market conditions have also fundamentally changed dramatically in 10 years in the US for onshore versus offshore wind. Historically, offshore wind just didn't make any sense because it was about 30 cents a kilowatt hour. There were only a few big players. And the only reason to really do it compared to what used to be onshore wind was if you had a lack of land. And in the US, we had so much land with such great resources where the cost for onshore was about 1/3 of what it was for offshore, that it only made sense in places like Denmark or the UK, where land was super constrained and the price of electricity was so high to begin with, like 50 cents a kilowatt hour, that 30 cents a kilowatt hour didn't seem so ridiculous. Whereas we had 7 or 8 cents at the time probably as the price. Now, both of them have come down dramatically, right? Probably each by 1/3. So the gap is not as big anymore. And those low-hanging fruit onshore wind resources, the ones that were really attractive sites for development, are all taken. And now we're hitting this new phase where how do we get to the next stage of renewable adoption without those onshore sites anymore? And as Claudia mentioned before, there are significant understanding and depth of experience now that's come from 30 years in Europe. And there's also significantly more competition. There used to be only a handful of developers who were willing to take that kind of risk. And there were only literally 2 manufacturers 10 years ago who did offshore wind power. Siemens had 80% market share and Vestas had 20%. And now we have significantly more players, and we have oil and gas companies who are looking to develop because it's an area of expertise that they understand. And Ørsted from Denmark led the way in that transition, and others are now following. So you have, I guess you could say, much more fertile ground about the conditions that make a lot more sense, and you have a lot more competition. And I think also a lot more, political motivation to make those things happen.
Yeah, I'd love to build upon that piece around offshore oil and gas. I think about 15 years ago, people got really excited about hydraulic fracturing because you could, drill a mile deep and then 2 miles sideways. And they were going out to such remote places to access natural gas and oil. We saw companies going to Siberia and the Arctic and cracking ice in order to extract what they thought was black gold. And now it seems so absurd that people went through those extreme measures to get access to crude oil. And then building out offshore wind, although it still falls under the mega engineering category, is so much more kinder to the environment, so much better for society. And furthermore, when we talk about not just transition from our energy mix, careers and jobs for people who already have that expertise, who are accustomed to living on sea, understanding how to utilize underwater pylons and welding and all those things that are going to create jobs for people who historically have been shut out of the new green economy.
Yeah, and I think it's important what Nneka's talking about too, with those prior industries and how much they can actually help us. We've got the luxury of having a really robust onshore wind industry, and then we have the learnings from our European friends who have done a lot in offshore wind. But we also have our own history of offshore oil rigs, and in some ways it's a very reassuring precedent that what they've done. It's quite impressive what they've done, and we can learn from that. The structures they build out at sea, and being able to transmit what they use, what they do now. We would need to do those same things for offshore wind. So we need to capitalize on those kinds of experience, especially since offshore wind isn't something that we've done a lot of. We have, I think, 7 turbines in the water. So it's really important what Nneka mentioned, is that learning from those other industries and experience.
That definitely makes sense. It feels like there's a lot of pressures and opportunities for offshore wind in the near future. What are some of the countervailing pressures? Do you think that there's still tensions from the failure of Cape Wind? Do you think that it's a lot of regulatory issues? Why haven't things moved faster, do you think?
Yeah, I think the planning and permitting for offshore is daunting. It's tough for an onshore project. It takes still multiple years to develop an onshore project, and offshore has a lot more factors and significantly less precedent. And on top of the actual offshore turbines, you need the grid access. And that is quite complex as well. So, I think the momentum is driving in the right direction. But, at the end of the day, as Claudia said, this is still a really big project. At Siemens, offshore wind was considered category A project, meaning the biggest possible project the company could create, and only a handful of project managers across a 400,000 person company would be allowed to lead a project like that. So just to give a sense of the scale of how challenging this kind of project is to build. That being said, once it's built, as Claudia mentioned, it can be built at a much more significant scale, and the capacity factor is much higher. So, it takes more energy in, but it, no pun intended, brings more energy out.
Okay, that definitely makes sense. Sorry.
Going to say there's the challenge of people being able to focus on more than one thing. I feel like for a long time, I remember when wind was being built, and then our attention went on solar, then our attention is on EVs. So sometimes it's just like a lack of folks thinking about it and prioritizing it as a level of innovation that we need to focus on. I mean, we're not perfect in any level of deployment of renewables across our country, and just ensuring that it gets prioritized the same way that we're prioritizing things like high-speed rail and other stuff.
Yeah, and I listening to both Nina and Nneka mention something that I know it came up in our previous conversation about how something like offshore wind, and for Atrevida Science, we're pretty focused on our area, which is blades, but our EIRs, our mentors are always pushing us to think about the entire ecosystem. And I know one of the conversations we had recently was that, each time you talk about deploying something like an offshore wind farm, each aspect of that is like a mini ecosystem. I think that's the exact term that Nneka used, that it's an ecosystem that is pretty big in itself. And so I think the example you gave, Nneka, in our conversation was that, you might have a vessel that has, $1 million a day to go out and service an offshore wind maintenance issue, for that example. And then for something like a solar farm, you have to find the people that can mow the grass around it. So, you're talking about all kinds of issues that people in my situation, sometimes we're really hyper focused on just what we're doing, but we have to remember that outside of what we're doing, there are so many other parts of making sure that offshore wind or any other renewable is successful. It takes a little ecosystem for each of the aspects of making that project happen.
And one thing I also forgot to mention, and I'm certainly not an expert on this, but something I learned during my time in wind power, is that the conditions in terms of where can be developed in Europe are actually significantly more attractive than they are in the US. Until we hit a point of floating turbines, which I know the innovation is getting there, but we're not there yet. In the North Sea and in the areas around the UK, also in the North Sea, it's quite shallow for a long depth, very far out. And in the west coast of the US, there's almost nothing like that. And in the East Coast, there are very few places that are attractive like that. So you don't quite have the level of development opportunity that you did, unfortunately, in Europe. And I'm sure we'll have all sorts of innovation to account for that, but in the short term, it's definitely a barrier.
That definitely makes sense. So looking at this sort of complex renewable energy landscape and everything going on, aside from the wind innovations we've talked about today, what are some innovations that you're really excited about?
I think to Claudia's point, and I know that this is nothing new, but I'm pretty excited about renewable hydrogen and renewable fuels in general. I think hydrogen is just one, and we're kind of seeing the tip of the iceberg of like renewable aviation fuels and other sort of things that can be drop-in replacements for what we're used to in the past. And I think the ship has sailed on both solar and wind power, in that there's a massive amount of competition driving those industries forward. So it's very exciting to see that innovation, and we're going to continue to see the costs come down and the deployment increase and increase, which is just thrilling to see that momentum. But in energy storage, I think we've already come a long way, and we still need huge catalysts from policy and regulatory and those kinds of stake in the ground that will make sure that those technologies advance. And once the as was mentioned before, once the economies become attractive, then it'll go to all corners of the world. And hydrogen never had that stake in the ground. To get past that barrier, it's still so expensive. And we're finally starting to see the regulatory catalysts to make hydrogen really happen, the way that solar and wind power and more like lithium ion energy storage have had those catalysts in the past. So I think that's an area that we're just starting to see the beginning of what will be a dramatic wave of innovation.
I'm excited, and I would say this is probably like a basket of technologies, but technology that allows for people to take energy autonomy. There are dozens and dozens of utilities in this country that still rely on coal power. We're having this conversation about renewables and new technology, but there's actually a lot of really good technology that's established, but there isn't always a clear way for people to have access to solar or storage or wind where they live. If there's an opportunity to do community or software or some sort of implementation financing, those are the technologies that really excite me. Because when Claudia builds her wind turbine, I want someone in a regular part of town to be able to get access to clean energy. So I think it's great when we build it, but it has to be built for people. It has to be built for use. We're still trying to figure out how to integrate the technologies that we have. And I'm really excited for the companies who have thought about bringing in all the stakeholders and how folks are talking together. I just saw a question from Laureen about microgrids, and it's like, microgrids have been around for such a long time. How do we make microgrids ubiquitous? How can they be, inexpensive and more useful than they have been in the past?
And I think that that's a really good point to make about the grids, because I think traditionally we've had this one-way direction. So we consume the energy, but now we need to think about it a little differently, and that is that we want to send some back. And there's places in areas that you hadn't thought of, maybe in New York City, that have their own little microgrid, and they are using that to power all their needs. But then when they have excess energy, they're sending it back to the grid. And so we have to get to a place where there's that bi-directional relationship with renewable energy. And so that's a big change, because our grids aren't really equipped to do that, today.
So in the long run, as we think about a smarter, more resilient grid, do we see microgrids sort of summing up into the larger grid as a smart construct, or how do you see that working out in the long run? Does the grid just become the sum of its parts, or?
I find this to be challenging, because a lot of technologies are developing in tandem. So when we're talking about microgrids, usually we're talking about solar plus storage, maybe steam, maybe, there's all sorts of setups, but you're also talking about microgrid controllers, you're talking about DERs and all the things. It can be as complicated or as simple as you want it to be. But the big thing about that is around collaboration, the source and sink of the energy, who's benefiting and who's paying for it. I think complicates a lot of things when it comes to microgrids. If at the same time that people are trying to put those together, that there's another type of technology that allows for folks to make decisions on their own that would benefit them and their communities without having as many principal agent problems, I think that would be better, but I wish I had a crystal ball because I would invest in that company.
Definitely fair. Another question from Q&A. Claudia, do you see any opportunity for offshore wind on the Great Lakes, or do you think it's primarily going to be offshore in the, traditional standard of ocean?
Well, I think that, we're starting out on the Northeast coast because it's a no-brainer. The people have called it the Saudi Arabia of wind. So it's an excellent wind resource. I think the intention is obviously then move to the West Coast. Like Nina mentioned, there's, deeper waters. That's definitely going to require the floating offshore technology, which is something that's coming down the pipeline as well. And then, the Gulf Coast, you got to deal with hurricanes. But I think that there's technologies that are being looked at to address those kinds of extreme weather events. And then when you talk about the Great Lakes, you're talking about extreme weather conditions there too, the cold, the ice, and they're developing a lot of really good technologies for, leading edge erosion, for reducing that, as well as, for ice conditions and coatings that can mitigate some of that. And so I just think that we're going to take that first step on the Northeast coast. And then as we learn and as time goes by and we get better at that, we'll have floating offshore. And then we'll just continue to do that, on each coast, basically. And that's pretty exciting, and I hope I'm around for all that still, because this stuff takes time. It's floating wind is exciting, but we're still trying to figure out just traditional offshore wind here in the U.S.
That definitely makes sense. So we've got about 5 minutes left. So as we're sort of winding this down, I'd just love to get some closing thoughts from all of you on what you're most excited about here and how you're feeling about the future. And what you'd like to see in the next 5 to 10 years.
I'm very excited about the future. When I started my career in alternative energy, I was like the only person in the room who believed it could be real. And now I don't think there's any question that we know that it's the future. It's sort of ubiquitous across industry, across government, across even the public. So I think we are definitely not just hit the tipping point. I think we're past the tipping point of this momentum. It's just a question of how fast can we get there. And I think that's why all of these conversations are really exciting. And I've said it many times, economics is what will drive this at the end of the day. And those policies and that incentive and all of that just helps to get to the competition that gets us down in cost. And I think we're there. So I'm really excited about the future.
And I see the focus and the emphasis on what we need to do to combat some of our climate change issues as really, really, the timing is right for this. And hopefully we can still do all. That's why we're all working really hard. And I can remember in the 90s when I lived in Texas, they would have these things called ozone action days. And we weren't supposed to mow our lawn. We weren't supposed to get gas because of the air pollution. And 20 years later, still living in the same place, we didn't have those ozone action days. I don't think we had them anymore, or if we did, they were much fewer and farther between. And so there is the power to make a change. There is, we have it within ourselves to do this. And there's so much support with, listening to Jigar Shah and some of the programs that he's working with and the market forces. This is a really good opportunity. And I'm pretty excited about it because I think there's a lot of great technologies, and like he mentioned earlier, it's not always about cost and how cool and great it is. There has to be a demand. There has to be a customer there for it. And I think we have
that. For me, I think it's just so much excitement that there are so many people paying attention to this climate crisis and working on it. The fact that we have this summit and so many amazing panels and speakers is just phenomenal. People have been saying these things for a while. If you take it all the way back to like Upton Sinclair in 1906 wrote a book called The Jungle, talking about conditions of industrial workers and the meatpacking industry. And then you went all the way to like 1962, I think. Rachel Carson wrote Silent Spring, railing about pesticides and environmentalism. And all of these people, we look at them now as pioneers in these fields, but it's also been more than 100 years that folks have been saying, hey, there's something wrong with the ways that we have been building up this country. I'm happy now that, we're mostly on the same page to say here in 2021, we're in climate chaos and we can't keep building and doing things the way that we used to. The question is, can we accelerate fast enough in our discovery and our implementation so that we're not writing a book in 2051 saying the people in 2021 should have worked a little bit faster. So I'm not so worried about that because I think human beings have the ability to come together in times of crisis and work together, but I wish it didn't require us to be in a crisis for this to happen. But otherwise, I'm really excited for people using their time and talents to create all sorts of amazing businesses, and I'm really excited to see, what the future is going to look like, and to be able to say that I use offshore wind one day.
Great, thank you all. It's been wonderful to have all of you here today. Wonderful to get your insights and all of your thoughts about this. So just as we're closing up with this, in 2 minutes, we're going back to the main stage.
Hey, Devin, I think you're on mute accidentally, maybe?
Sorry, not sure how that just happened. Sorry, I was just saying that after this panel, we'll be going back to the main stage for Shante talking with Kelly Belcher from Silicon Valley Bank about his most recent work, and then we'll be getting back to some more panels. Thank you all for being here, and to our panelists, thank you so much for joining us today.
Thank you,
Thank
Devin and Claudia and Nneka.
Thank you.